All right, so today for equations, we are going to be solving type 3 equations. So just for a quick review, here on the bottom, we just did a review on solving a typical type 2 equation where we have one term with the x, and we're just solving for x, and we isolated x on the left-hand side, and we solved for x here, and x was equal to 4. What we're going to look next are these type 3 equations. The first step to working on these type 3 equations is something called collecting like terms. So I'll show you that in a second. But what we're going to do is we're going to collect like terms, and we're going to put our variables, which are usually our x, we're going to put that on the left-hand side of our equal sign, and we're going to put our numbers, which are our constants, we're going to put those on the right-hand side, and then we're going to solve for x. Keep in mind again, we're still doing opposite operations. So anytime you want to bring something over the equal sign, you have to use the opposite. Okay, so again, anytime you're trying to bring a term over to the other side of the equal sign, you have to do the opposite operation. So let's take a look at some examples. Oh, firstly here, just as before we start solving, this is just showing us how we can combine like terms. So let's say you have the expression 5x plus 9 plus 2x, okay, which is shown here. We can collect these two like terms because they are like terms. They both contain the x. So 5x plus 2x gives us 7x, and then we would have the plus 9. Okay, so that is how we would combine like terms. So our final expression here is 7x plus 9. All right. So let's take a look at this example. We're solving for n. It'll just say solve 7n minus 2 equals 5n plus 6. That means we're solving for the variable. In this case, the variable is n. So notice here, we have n on the left side. We also have n on the right side. So to bring this over to the left-hand side, we have to subtract it. So that's what's being shown here. So we're subtracting 5n. We're subtracting 5n on both sides. All right, and you're keeping the like terms together. So you're not subtracting 5n from the 2, you're subtracting it from the 7n. And that'll cancel out on that side. And then we're left with 2n minus 2 equals 6. Now we need to bring this over to the right-hand side. So opposite operation again. You're going to add 2 to both sides. It'll cancel on this side. Now we're left with 2n is equal to 8. Last step is to show that we're dividing. 8 divided by 2, and we'll end up with our answer here, n is equal to 4. And again, we can do a quick check to make sure that does work out so that the left side is equal to the right side. So 7 times 4 minus 2 has to equal to 5 times 4 plus 6. So on the left side, we have 7 times 4 is 28, and then 28 minus 2 is 26. And on the right side, we have 5 times 4 is 20, plus 6 is 26. Left side is equal to right side, so that means we did do that correctly. Okay, so let's try an example here. 4x minus 3 is equal to 2x plus 13. So we need to collect like terms. So for this example, 4x minus 3 is equal to 2x plus 13. The 2x we see on the right side as well as the left side. So we usually have our variable on the left-hand side of the equal sign. So that means we have to move the 2x over to the left-hand side. And because we're moving it over the equal sign, you have to do the opposite. So the opposite of 2x is to subtract 2x. So we're subtracting 2x from both sides. All right, so on the right side, 2x minus 2x, that's gone. On the left side, we have 4x minus 2x, which leaves me with 2x, minus 3 is equal to 13. I'm just going to pause here. All right, so now that we have brought this 2x over to the left-hand side, and we've simplified our equation a little bit more. We're left with a type 2 equation. So we have 2x minus 3 is equal to 13. Our next step now is to add 3 to both sides. Now we're left with the left side. We have 2x is equal to 13 plus 3, which is 16. And lastly, we're going to divide by 2 on both sides, which leaves me with x is equal to 8. All right, so here we have our second example. So we have 5x minus 3 is equal to 3x plus 14. So again, we have an x on the left side. We have an x on the right side as well. So we want to bring this 3x over to the left-hand side so that we can collect the like terms. So it's a positive 3x. We want to bring all of 3x over to the left side. So we're going to subtract 3x. And we're going to subtract 3x. We're bringing all of that over. So on the right side, 3x minus 3x, that cancels out. On the left side, again, I'm subtracting the 5x minus the 3x. All right, you're not going to put it underneath here. That's the constant number. You're subtracting or collecting like terms. So 5x minus 3x, that'll give me 2x minus 3 is equal to 14. Now it looks like a type 2 equation. We're going to add 3 to both sides. Okay, negative 3 plus 3, that's gone. We're left with 2x is equal to 14 plus 3, which is 17. And then we're going to divide by 2 on both sides. And here you can put it into decimal form, or you can leave it as 17 over 2. So 17 divided by 2, if I put it in decimal form, it's 8.5. All right, so for this example, we have, here's our equal sign. On the left side of the equal sign, we have a 3x plus 5x, and then a minus 4x. But we also have a positive 1x on the right-hand side. So before I move anything across the equal sign, I'm going to go ahead and simplify this equation a little bit. So 3x plus 5x, that gives me 8x, minus 4x will give me 4x. So on the left side now, it looks like this, 4x plus 7 equals 19 plus 1x. Now I can go ahead and move things across the equal sign. So I will subtract the 1x here, subtract the 1x here. Okay, it cancels out there on the right side. On the left side, I have 4x minus 1x, which is 3x. Plus 7 is equal to 19. Now it looks like a similar, a familiar type 2 equation. So here now we're going to subtract by 7. Subtract by 7. Now we have 3x is equal to 19 minus 7, which is 12. And now we can go ahead and divide by 3 on both sides, and we're left with x is equal to 4. So with this question, we had an extra step, which was combining like terms. On our left-hand side, we were able to combine the 3x, the 5x, the negative 4x, combine those together, and then we moved the 1x over to the left-hand side. All right, so for this example, we had 6x plus 4x plus 2x. It's all on the left-hand side of the equation, so we can collect these and combine those like terms together. So 6x plus 4x plus 2x, that gives me 12x equals to 48. So now it just looks like a type 1 equation. It's 12 times x equals 48, so opposite of that would be to divide. Divide both sides by 12, and that leaves me with x is equal to 4. So for this next question, we have 5x plus 2 equals 3x plus 18. So we have x on the left side and we have x on the right side. So for this question, we need to bring this 3x over the equal sign to the left-hand side. So because we're crossing the equal sign, we have to do the opposite operation. So we're going to subtract 3x from both sides. All right, so that's our first step, is to bring all the x's over to the left-hand side. All right, so 5x minus 3x, that leaves me with 2x plus 2 is equal to 18. So we have 2x plus 2 equals 18. Now it looks like a type 2 equation. So now we're going to subtract 2 on both sides. So on the left side, we have 2x. And on the right side, 18 minus 2, which is 16. And now it looks like type 1 equation. 2x equals 16. So we have to divide by 2 on both sides. And that leaves me with x is equal to 16 divided by 2, which is 8. So there's the answer. X is equal to 8. Okay, so we have a typical type 3 equation here where we have an x on the left side. We also have an x on the right side. So we have to bring this over the equal sign. So we're going to subtract the 5x on both sides. Okay, so on the right side, 5x minus 5x, that just cancels out. Here on the left side, we have 9x minus 5x, which leaves me with 4x plus 2 is equal to 30. Now it looks like a type 2 equation. We're going to subtract 2 on both sides. That leaves me with 4x is equal to 28. Now it looks like a type 1 equation. So last step, we're just going to divide by 4 on both sides. And that leaves me with x is equal to 7. All right, this equation here, on the left side, we have a 10x and we have a negative 5x or a minus 5x. All right, we don't have an x on the right side. So here, because they're all on the same side of the equal sign, we can just collect those together. So 10x minus 5x is 5x. So 5x, and we have the plus 75 is equal to 110. Okay, next we are going to subtract 75 on both sides. All right, so 110 minus 75 is 35. So 5x equals 35. And then we're going to divide by 5 on both sides. And we get x is equal to 7. All right, so a really good question here is, how are we supposed to know when to combine? So it depends if they are on the same side of the equal sign. So here the 10x and the negative 5x, they're on the same side of the equal sign. We're not moving across the equal sign, so you can combine those together. Here, we had a 9x on the left side of the equal sign, and we have a 5x on the right side of the equal sign. So anytime you're moving across the equal sign, you have to do the opposite operation. All right, so I'm going to pause here